Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through kinematics, which is just displacement, velocity, and acceleration. Now, we already looked at this topic when we're doing differentiation, but now we're going to look at it in terms of integration. So what we want to do is be able to find displacement and velocity when we know the acceleration. Now, we learned before that if you differentiate displacement, you get velocity. If you differentiate velocity, you get acceleration. Velocity is the first derivative of displacement. Acceleration is the second derivative of displacement. So velocity and acceleration are just rates of change. Velocity is the rate of change of displacement with respect to time, and acceleration is the rate of change of velocity with respect to time. So we learned when we did the total change video that if you have a rate of change and you integrate it, you get the total change. So that means if I know the acceleration and I integrate it, that'll give me the total change in velocity. And if I integrate velocity, it gives me the total change in displacement. So we're going to apply these concepts to this question here. So car traveling at 15 meters per second decelerates at 3 meters per second squared. How far will the car travel in the first 3 seconds and also before it stops? So what I really want to do to answer A, find out the total change in displacement of the car in the first 3 seconds. So really, I want to integrate velocity from 0 to 3. The problem is I don't have the velocity function yet. So I'm going to need to first find the velocity function. So I know that acceleration is actually minus 3. So that's because it's decelerating at 3 meters per second. That means the acceleration is minus 3 meters per second squared. It's losing 3 meters per second of speed, of velocity, each second. So in that case, velocity will be the integral of acceleration. Now here, I'm not going to put values for t. I'm just going to integrate, do the indefinite integral of acceleration with respect to time. Here, I'm not asked to find like the change in velocity in the first 3 seconds, in which case I put 0 and 3. That's why this is an indefinite integral. You see, if I used a definite integral for velocity, I'd get one number, like 4 meters per second. If I then tried to integrate that over here, the integral of a constant wouldn't work. So what I need to do is find the velocity function. So velocity will be the integral of minus 3 with respect to t. So displacement, velocity, and acceleration are all functions of t, which is time. In this case, t is going to be in seconds. So the integral of minus 3 with respect to t just gives me minus 3t plus some constant. Now, if the car was originally traveling at 15 meters per second, that's telling me that the velocity when t equals 0 is equal to 15. So if I were to substitute velocity for 15 and t for 0, I'd get c equals 15. So because of that, I get velocity function is minus 3t plus 15. Now that I've found the velocity function, I can integrate it to find how far the car has traveled in the first 3 seconds. So it will just be the integral from 0 to 3. This time I'm told I want to find displacement change for the first 3 seconds. That's why there are numbers there. The integral of velocity, and of course it's with respect to t. So integrating this, I increase the power of t by 1, divide by the new power, and the integral of 15 is t. Now, because I'm finding now a definite integral, I don't need to worry about the constant of integration. So if I put in t equals 3 into this formula here, I get 31.5. If I were to substitute t equals 0 into this, well, that would just be 0. So it's 31.5 minus 0. That is my change, 31.5 meters is how far the car will travel in the first 3 seconds, which is the total change in displacement. All right, let's now answer B. How far would the car travel before it stops? So it will stop when the velocity is equal to 0. So velocity equals 0. If this equals 0, t would have to be 5. So you get minus 15 plus 15 equals 0. So really, I'm being asked how far the car will travel in the first 5 seconds, because it stops after 5 seconds. So rather than go through the whole process here, I've already done the work. It will just be, this is the function for displacement, the integral of velocity, but this time I'm going to evaluate between 0 and 5. So if I substitute t equals 5 into this equation here, I get 37.5. Once again, if I substitute t equals 0 here, I get 0. So actually, the car has traveled 37.5 meters in 5 seconds. And this is the total distance it will travel before stopping, because it stops when velocity equals 0. And velocity here will equal 0 when t is equal to 5. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.